Hello folks, in this video I am gonna show you how you can contribute to Pi4Micronaut project. Let's get started. So this is the documentation. Here there is a section number 3 says contribute to Pi4Micronaut library. These are the step-by-step process like how you can contribute to library. So I'm gonna walk you through this. First we are gonna navigate onto the Pi4Micronaut repository. So this is the repository and you can access the documentation from here. Let's start with the readme.md file. Here is an overview of Pi4Micronaut. And the technologies used. You have to get familiar with Java, get familiar with Micronaut framework, and also the Gradle, like how you can run the Gradle projects and get familiar with the Gradle commands as well. Get a basic idea of Pi4J library, what hardware interfaces it provides, and how you can access them in our Pi4Micronaut application. These are the basic links for the already implemented API references and where you can find our library to access in other applications. If you want to access our artifacts like the jar file for our library, you can find it over here. And let's understand the architecture diagram of Pi4Micronaut first. So let's consider a Java developer. He want to develop a Java IoT application. It's nothing but the Micronaut application where he can have the controller classes and he has to set up his circuit and define the configuration in the application.yaml file, including with the other implementations which he require for the IoT application. And then he builds the jar file, SSH onto the Raspberry Pi, run this jar file to test the components which are connected to the GPIO board. This is the external perspective. Let's see the Pi4Micronaut developer's perspective. So let's focus on this. In Pi4Micronaut, there are two submodules. There are two sub-projects called Pi4Micronaut Utils. The other one is the components. So let's start with the Pi4Micronaut Utils. This is crucial for our Pi4Micronaut library. We have utilities, we have helpers, and we have docs. The utilities are nothing but the Pi4J's hardware interfaces. We are gonna make microservices out of it, which are required to interact with the GPIO pins on the Raspberry Pi. And the helper classes are nothing but the components and the functionalities which we are going to define. Let's say we have a sensor that you need to implement or include in Pi4Micronaut library, then you have to define all the functionalities under these helpers. We have categorized the helpers in two things based on the component functionality. Let's say the LED. LED is an output kind, it emits a light. So we have defined the LED under output component section. And for every implementation, you have to include your new documentations in the docs section. Once you build this submodule, we are gonna obtain a jar file called pi4micronaututils.jar. This is what we are gonna publish in the Maven central repository that the others can be able to access in their application by adding the dependencies. So this is the crucial part of our Pi4Micronaut project. So we are writing the functionalities and we are providing the support, but before we publish we have to test it by ourselves, right? So this component submodule comes into play. The components is like how other users can be able to access the component. It gives an overview and also it helps us to test our components. So we are gonna have the controller classes for all the helpers or for all the components which we have defined under the controller section. And for the configuration part, like based on what configuration you have set up your circuit, you're gonna define that in the application.yaml file. Once you run this submodule, we're gonna get a components all.jar file, which you are going to copy onto the Raspberry Pi and run the jar file, so that you will be able to test the components and the functionalities of the components which you have defined in the helpers. This is the Pi4Micronaut developer's perspective. So to access the Raspberry Pi, we are gonna use SSH connection. And if you want some example projects like how you can use Pi4Micronaut library, you can access these and take a look over here. And you have to note that we currently use Micronaut version 3.7.3. So there is a documentation and user guide. If you have any questions, you can go through this. And this is the Pi4J documentation, and we are currently using Pi4J version 2.4.0. Shadow Gradle 7.1.2 we are using right now, and this is useful to build or include all the dependencies in one jar file. That's called shadow jar. And if you are trying to contribute to Pi4Micronaut, you make sure you have to sign the CLA. Without that, your contribution will not be validated. Let's clone the repository and take a look like what are the components that includes. So to clone the repository, click on the code, copy the HTTPS link. I'm gonna click new folder, Pi4M. I'm gonna open a command prompt window here, cmd. This is the folder which we have created. So now the command is git clone, paste it. We have successfully cloned the repository. Let's look into it. This is the Pi4Micronaut project. So I'm gonna open it in any of the IDE. I prefer IntelliJ. So let me open the project. Open under the desktop, under Pi4M folder. This is our clone repository. Let me open that. Let the Gradle complete the build. So it's done. As I said earlier, while explaining in the architecture diagram, we have two submodules called one is the components and the other one is Pi4Micronaut utils. Under this source main Java, you can find all the controller classes. This is to test and provide an example implementation for other users, like how they can interact with the particular component. For example, this is the LED part, and this is how you define the controller class. You have to have a @controller annotation, and this is the endpoint that you need to trigger to access the LED and all of its functionalities appending that. To fetch the configuration, I mean the circuit setup which you have done, that you need to define under resources application.yaml file. This is where you have to paste your configuration. But before that, you need to identify and understand the component's anatomy, like how it functions and what communication protocol that it uses. For example, an RFID scanner uses an SPI type communication protocol. So under Pi4J, in the section SPI, we have to define the component configuration. And let's talk about PWM. These are the components which we provide support for currently, are PWM type, and we defined under PWM with the name of the component and the address, and this is the specific format required for the PWM kind, and it's different for the other communication protocols. So you have to follow this as per the communication protocol the component uses. Let's say for the LCD 1602, it uses I2C kind communication protocol, and these are the three required fields which we need to define the configuration. The LEDs or the photoresistors, buttons, these are the kind like digital input, and for the LED is a digital output kind. See, it is defined under digital output. So this is how you have to define your configuration in the application.yaml file. And let's get into this second submodule called Pi4Micronaut utils. Under source, we have docs. We are using ASCII docs to build a Pi4Micronaut documentation. So all of the documentation part goes in here. And this is the style.css where we have the basic style for our Pi4Micronaut documentation. In future, we need to update it. And these are the Java docs, basically for the API references. So let's get into the code. Under main Java, under this package, we have three things. One is the input devices, like based on the functionality, we have categorized them into input and output devices. These are the input kind and these are the output kind. So if you want to provide support for a new component, you have to identify whether it is an input or output, and based on that you need to create a helper class under these sections. So let's open one of the helper. So this is how you define it. And the most important thing is the utilities. Under this we have Pi4J factory. Pi4J provides different hardware interfaces for the communication protocols that required by the Raspberry Pi to interact with the GPIO. So we are gonna create the context for each of the communication protocols. This is for the digital output, this is for the digital input, this is for the PWM, and this is for the SPI, this is for the I2C configurations. So, and we have defined an interface, or you can call it as an abstract class, where you can fetch the configuration from the application.yaml file. It follows a structure. First, the configuration is from the application.yaml fetched on to the controller, then it passed on to the LED helper, and then it will be passed on to the Pi4J factory. And we are gonna fetch each of these by using the abstract classes which are defined under the utilities for each of these different communication type configurations. So this is about the utilities. By using these configurations, you're gonna build or implement the functionalities of a component. Here is the workflow of Pi4Micronaut project. Uh, as I told you earlier, we are defining the configuration in application.yaml file, and we are fetching that configuration in the controller using @named annotation. In the controller, we are gonna create an object for the helper class for the particular component. Through that object, we are going to pass the configuration onto the helper. From there, we are using Pi4J factory to create the context for each of the communication type protocols, and these are available for the whole application lifecycle. We have beans for each of these communication type protocols. So based on the component, it actually fetches the configuration onto the beans which are defined in the application.yaml file. We have Pi4J multi-pin factory where it is used for the multi-pin components like RGB LED. For now, we have only one or two multi-pin components. Like we are creating context for the multi-pin components in the Pi4J multi-pin factory, and these are the two bins for the multi-pins. These bins are residing in the jar file and are available on the Raspberry Pi and can communicate with the GPIO pins, and which lets us access the components which are connected to the GPIO. So once you build the project, we're gonna obtain two things. Let's build it. To build the project, we're going to use Gradle W build. So the build is successful. Let's see. Under components, there is a build. Under that, you can see the libs. So this is what we need to test out implemented functionalities of the components. So you need to copy this jar file onto the Raspberry Pi using scp command to run it on the Raspberry Pi. And the second part is, under this you're gonna obtain the Pi4Micronaut utils version 1.1.jar. This jar file, that if you have a handful of components and you want to make a release, you have to use this jar file. We have automated it, but this is the main important jar file that all the necessary functionalities are underlying in it. And how you can build the ASCII doc, we have a command called gradle w ASCII doctor. You can find it under, yeah, you can see the docs here. This is what we built right now, the ASCII docs. You can open this in the browser to locally test the documentation, and the command to build the Java docs is gradle w java doc. So the build is successful and you can see the Java docs right here. And the Java docs are used for API references. Make sure you work on the develop branch rather than main branch. Only when you have to publish your library, then I suggest you to merge the develop branch into the main, and the process was automated. Then you have to access the sonotype repository and you can do the publishing. Let's get into the Pi4Micronaut repository and you can find the latest releases over here. These are the contributors, and make sure you create an issue. If you're working on a existing issue, make sure you assign it to yourself, or if you are working on a new component, create a new issue, click new feature request, add the title, and make sure you have all the necessary information here. Make sure you add the proper labels and assign it to yourself. And then once you made the contributions, if you want to merge it onto the develop branch, what you have to do is create a pull request. So make sure you select the develop, and then you're gonna choose your branch which you are currently working upon, and then create a pull request. You can request reviews from any of the authors or the previous contributors so that anyone can look into it and they can give the feedback based on your work. Once everything was proper and you have signed the CLA, if you made a valuable contribution, then we will be able to merge your contribution onto the develop branch. When we have a handful of components, then we are gonna release it onto the Maven Central repository. Pi4Micronaut project has two submodules, right? One is components and the other one is Pi4Micronaut utils. Each of these submodules or subprojects have their individual build.gradle files. So the main important build.gradle file is under Pi4Micronaut utils, where we have defined all the dependencies which are necessary for the library, and also we are building the ASCII docs, we are building the Java docs, and also we are defining how we can publish the library onto the Maven Central repository using sonotype credentials. This is the URL for the release and this is for the snapshots. You can get the credentials from Daniel or Dr. Holner. And also for the documentation part, we have deployed them on the GH pages branch. So this is our repository and you can see the branch named GH pages where our documentation was published and it's accessed through this URL. And also you can see the workflows which we have defined. This is for building the ASCII docs, and this is for building and releasing the library onto the Maven Central repository. This is to build our project, and this is to publish the documentation in the GH pages branch. And how you can see release library, you have to navigate to the Sonotype repository. This is the URL. This is called Nexus Repository Manager. So let's get into it. So first you have to log in with the credentials. Once we log in, we can find the staging profile, staging repositories, staging rule set, staging upload, and we are going to click on the staging repositories. So whenever we have merged anything onto the main branch, we'll see the particular release information over here. What we have to do is we have to click on it, close the repository, and if you want to promote, you can promote it, or else once you close it, you will be able to access a button called release. Once you click the release, you can see the new version of Pi4Micronaut library in the Maven Central repository. It might take some time. Let's navigate to Maven Central. Search for Pi4Micronaut utils. And if you in the future, if you release a new version, it's gonna show you as version 1.2 or 2.0 based on your release version. So that's how we manage our release. That's it for this video. Thank you.